You can incinerate, you can recover, you can capture the CO2. Do you really need to recycle plastics? I don't know.
Hello. I'm so happy today to finally have Dr. Alexey Vishtal, my friend.
Honestly, the only reason why I ended up working with paper is that's because I didn't want to go to army.
You worked for the longest time with Nestlé. What were the highlights? What were the lowlights?
The big corporations actually may be even better sometimes in terms of their ethical behaviors in the small companies.
How should they make a change so that there is a faster adoption of more sustainable substrates?
There should be maybe a little bit less of the secrecy and a little bit less of the fluff.
It is a finite resource. At some point, we will, as humanity, move away from it.
Would they be happy to see paper there, or they would be more unhappy about increased price of the product? It shouldn't lead to the increase for the purchasing price for the customer.
How is nature solving it compared to what we are trying to do?
Yes, there are nuclear reactions in the stars, but we are able somehow to reproduce it and use it for energy.
You have to be you, Alexey. You are unique, and that's the way you come, and you embrace it well, and that's what matters. Hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? Hello. I'm so happy today to finally have Dr. Alexey Vishtal, my friend, partner in crime in some ways, a person I've looked up to in terms of getting guidance, and somebody I truly respect in the field of packaging and sustainable packaging. And also, like we were discussing, Alexey, right before, that he's also the master of Quas. And we won't tell you right now what Quas is, but maybe during the conversation, we'll bring it back up. But thank you, Alexey, for taking this opportunity.
Well, thank you so much, Red. It took us some time to get it to work. I mean, there's this podcast recording, and I'm happy to have such an opportunity. I also hope that I have something to say which has a meaning. So let's see, maybe at the end of this conversation, if it's the case. And for sure, it's also my pleasure, to be here with you, because you also have taught me quite a few things when I was back in India, and not only.
Thank you so much, Alexey. So I'm going to start with things I know a little about, but I want to know a lot more. We know that you grew up in Russia, in the St. Petersburg region, but I want to know more about growing up. And if you can think of some early influences that led you to where you are today.
I'm generally a guy which goes with the flow, but then when I'm in the flow, I can maybe either move faster or slower. But honestly, the only reason why I ended up working with paper is that's because I needed to go to some university because I didn't want to go to army. And the lowest acceptance rate was in the university which was teaching the paper making. So it was a natural choice. Okay, I can get accepted there, and then at least I have a certain postponement till I need to join the glorious Russian army, and then I just went with the flow. And if you want to have a second postponement, you have to do a PhD. So that's why I did it. And when you get a PhD, you are too smart to go to army. So or maybe you are too dangerous because you can destroy it from the inside. Start to ask too many questions. So that's how I actually ended up selecting the paper. So it was not because I was caring about making paper out of the pulp or because I want to cut all of the trees in the world. It was just because it was going with the flow to avoid the army. Sometimes, the path is quite strange.
Yeah, life takes you in many directions. So I was going to ask you more about the pulp and paper, but you kind of answered it, and you also answered the PhD. But I'm going to switch to what made you go out of Russia and go and seek your PhD and another master's elsewhere. I think it was Finland, right? So what made you do that? Why not just continue to do it in Russia?
Well, honestly, at least in my opinion, at that point of time, which was, I would say, was it back in 2007, 2008, it was just, in Russia, if you look in general on the industry or in the attitude, it's more like, okay, we are living today, we don't know what's going to happen tomorrow. So there is more look towards the, let's say, immediate profit, try to monetize, try to ramp up quickly, maybe without thinking, okay, how it will work in 5 or 10 years. At least it was back in 2007, 2008. And then when I had a chance to go to Finland, first to do my bachelor thesis, I have seen that the people, first of all, they are not in the rush. They're super relaxed and they think, okay, look, if I do it today, they already start to think about the consequences, which it may have, in the 5 or 6 years. And also that brings a certain difference in the way how the people communicate with each other and interact with each other, because in Russia, people tend to be a little bit more in the rush, or they're looking for more immediate returns. It was more harsh style of the communication, while in Finland everybody was super relaxed, maybe sometimes too relaxed. And I said, okay, look, there is a possibility to learn, and I think the learning in this environment where you don't look like just to make something tomorrow, but you have time to grow the idea, and you have time to look on it from the different angles, from the technology, from the raw material, from whatever, could be a bit more interesting, I would say. But it was also a general way of exploring, because I was 21 or 22, and I have never been abroad before. So and Finland was the first country which I visited. So it was of course, kind of love from the first sight, because, well, you haven't seen anything else. Later on, when I realized that the climate also can be better, I started to love more southern countries. But at that time, it was, wow, could be like this. So completely different from what I have experienced.
Nice. So of course, I understand that you kind of entered or you stumbled into pulp and paper. But what is it that kept you in this business? Was it an early influence of, what you were studying? Was it something else? Or was it just, like by default that you just stuck to it and, you kept doing more and more work in the pulp and paper business? Was there something that really caught your attention?
Well, I think I was not really a great student either, at least for the first couple of years. I was barely surviving on just staying there. But I think on the year 3 of studies, you have this chance for the internship. And then first I went to see the pulp and paper mill. And when you see the scale, you see all the trees going on the conveyors, you see the digesters, that they're big. You see the pulp drying machine, and this is a whole sort of a small city within the city. When you see the scale, and you have realized, well, actually, it it does something. So because before, paper was okay, paper is paper, nothing fascinating. But when you have seen the whole sort of scale behind it, and how it works, and you think, oh, somebody have actually put some effort to get to an idea that you can take piece of food, you have to boil it or cook it, and then you can make a paper out of it. So that's interesting. And then I kind of really got the interest through the first practical interaction, because my first job was operator of the barking drum. So I was just taking bark from the trees.
Amazing. So I didn't remember this, or at least till we were researching that your thesis for PhD was paper stretchability, and that's
Yeah.
something you and I talk about still, and we explore, and of course, it changes the whole idea of paper if we can make it more stretchable or extensible. And of course, you have extensible sack craft and stuff like that. But were there things that you learned in that process that you could apply now to make it more stretchable?
Well, I mean, when it comes to stretchability, you can work on 3 levels. One is on the fiber level, so on a single fiber level. Second one is on the fiber to fiber bonding, and the third one on the fiber network level. In terms of the fiber is what, between 1 to 3 millimeter long. What you can do, you can try to compress the fiber itself, and that usually happens in a high consistency refining. So you can get a little bit more, because a single fiber extensibility is usually higher than the extensibility of the fiber network. And if you can compress it, it would be also improved. Second thing is the fiber to fiber bonding, or the interface, or we can call it fiber join, because if you can have a very strong bonding when it's very rigid, and then you get a very high elastic modulus, but your tensile energy absorption, or let's say ability to extent when the mechanical stress is applied will be limited. So you would like to have these fiber joints to be flexible. And here you can play around with adding like a layer on top of the cellulosic fiber. So you can add the extra hemicellulose. What I was using the xyloglucan. So it's also the polysaccharide, which kind of basically you have a, let's say the fibers as the two pieces of bread. So you put like a little bit of butter in between them so that they can slide. And the third option is a fiber network, and that's what you have mentioned exactly. It's a glue pack or any other compaction process scrapping. There you just try to compact the network, so you are let's say increasing a little bit the thickness, increasing the roughness because of this, but then the network becomes, let's say, more bouncy, and eventually you can get maybe to the with all of these treatments, with high consistency refining, with modification of the fiber joints, and with compaction, you can get up to the 35% stretch while maintaining the decent strength characteristics. Of course, in crepe paper, you can go much higher, but there it's you have no sort of strength when the paper being stretched.
So why don't people use the first two methodologies, or do they use the first two methodologies and we don't hear about it?
I mean, the high consistency refining or combination of the high and low consistency refining is quite common at the sack kraft mills. I mean, some people do it better, some people do it worse. But the fiber joints is not so common because it requires some wet end additives, or you can also apply it by spraying, and it's not always feasible, so to say. People are trying, I think, because starch to some extent does a similar thing, like for instance xyloglucan did, but it depends also on the type of the starch. So then you would look maybe more for a waxy starch to do it, and of course there are wet end starches I use. So I would say it is known and it is used, but whether it is used to its maximum potential, that is another question.
So there is hope to do more work in the stretchability region for sure. Okay, let's switch to, you worked for the longest time with Nestle. And I'm sure, that was an experience that taught you many things. So tell us, in general, what that was like. It's a huge company. How were they looking at it? What were the highlights? What were the lowlights? It'll be great to talk about that.
I mean, it was first of course, quite fascinating to join the biggest food manufacturer in the world, and to learn that they have actually interest to look more into the fiber-based packaging. So it came at that time. It was back in 2015. It came a little bit out of nowhere. It's like, okay, would you like to come for interview and so on? So I came, and I think I was maybe a little bit of anarchist still at that time, or you can call it the idealist. I was still like a little bit like, Nestle, big corporation. But at the end, I have learned that the big corporations actually maybe not, or I would say they may be even better sometimes in terms of their ethical behaviors in the small companies, because there are much more tools in that sense. And that, of course, was really interesting to learn that there is so much, let's say, the compliance levels you need to get through before you can actually validate that the new packaging or new packaging material is good to go on the market. And for sure, the food safety is one of the pinnacle, so to say. You cannot really start the development before you validate that whatever you're going to do would be food safe. And then at the later stage, when the pledges came on making all packaging recyclable or compostable, or I think it was reusable. I don't remember now because it was back in 2018. Of course, the whole movement towards launching something on the market have accelerated, and of course, the big benefit working for a big brand owner, that's more or less every door is open. So you come, okay, you're the biggest in terms of the turnover, at least within the food. You consume many thousands tons of packaging material, and if you come to any supplier saying, look, I would like to have a new packaging, let's say the traction is a bit better maybe than with a smaller company, but And that helps a lot when you try to bring the new things to the market. And I think that helped a lot also to put this. We put the Nesquik packaging, we put the several confectionery brands on the market, and there are a few other things which have been launched. So it was a great experience overall. I mean, and for me, if you would ask me whether I would want to work for Nestle again, definitely yes. But I have just learned that there are many more other things, and it's good to change the environment from time to time. So I did it twice. So first I joined Nestle, then I left to work with you. Then I rejoined, and then I left. But who knows? Maybe I will join again.
So it's great to hear there were changes, but why do you think the speed of change is it just because it's a large company? I find that the we've been talking to Nestle for years,
Mhm.
but the speed of change we find is very, very slow, and they would go a certain amount and then go back, and then of course we find that there's a lot of enthusiasm in the beginning, and then when it comes to paying a little bit extra, that doesn't go down very well, or maybe I'm reading it wrong. So how would you say, Nestle? So talk to me about how should a company like Nestle, and that could include
Mhm.
all big companies, Unilever and Mars,
Mhm.
etc., etc. How should they make a change so that there is a faster adoption of more sustainable substrates?
It's a good one. Of course, on one hand, you have organization, which can be quite complex. I mean, you could have a centralized R&D, you could have a R&D per category, you could have even the market R&D, and you have a set of the decision makers. But at the end, it's always a specific country or specific category which takes a decision to launch something. But before all of these parties can reach an agreement, it may take some time. And of course, also it depends very much on the people. So if there is a determined person who says, okay, I'm going to launch it on the market, I want it, then things happen. But if there is no clear decision maker or someone who will take the responsibility in case if it fails, things takes longer because there's this multi-alignment meetings, and eventually then the people also could change, and then you have to do it again. So for me, it's really the way how the organization is structured, which sometimes prevents going faster, but it's also an important mechanism for the big companies because every move of the big company could cause quite a lot of turbulence afterwards, and this is a sort of a self-regulation mechanism which helps to stay on the track sometimes, so avoiding some rapid decisions. So I'm not sure whether it's good or bad thing. Sometimes it could prevent from doing something which really shouldn't be done, but in many cases, it's also do not help to put the alternative packaging materials with better environmental footprint on the market. But what can be changed, I think, and that's also have been done now by many companies. They're putting the accelerators, so basically, and some sort of a entity within the entity with the different rules where the people can either do the entrepreneurship or they can work with external companies, and they are not bound by the procedures of the, let's say, the parent company. And I have seen that this is really helps to foster and accelerate the innovation. But then you still may hit a little bit the same problem, because eventually you need to find someone, even if you will finalize the concept, you get the cost, you get everything running externally, but then you still need to find someone to persuade to put it on the market, and that's again boils down to the people. But in general, answering your question, what big companies can do to accelerate the adoption of the alternative materials is really to put it a little bit outside of the standard routine through the accelerators, for instance.
That's a great suggestion. I hope some people listening might take it. I also see, Alexei, that there is a little shift in their desire for sustainability as the government pressure reduces. So, how much of their effort is based on regulation versus there is a certain desire in the customer in terms of a brand, or there is an internal, like you've worked with us, there is an internal desire for change. So if you look at three ideas that, there's government pressure, there is a demand from the customers that you become more sustainable, and there is just internal desire that we want to become more sustainable. What is it that drives companies the most? And does it really go down if the pressure is less from any one of these?
Let's look maybe on the origin of the, let's call it a sustainable wave, or because I think it's really a wave, because it reached its peak maybe a couple of years ago, and now it's gradually sliding down. So I think back in 2000, was it 18 or 17, there was a big report analyzing what is happening on the pristine, or what used to be a pristine beaches in Southeast Asia, and they just looked on who are the main polluters, or what are the most polluting items, and they found out that okay, there is of course some of the cosmetic items, but there is also a lot of the branded packaging. So there are the plastic bottles, but there is also the flexible plastic sachets, and the name a few big names of the brand owners. And of course, that has pushed these brand owners to move, because nobody wants to be associated and be called, as one of the major plastic polluters in the world. And then people also started to discover that this is a problem which is not a problem related to the material; it's a systems problem. So yes, you would like to offer an affordable product, let's say in a small sachet, because that's what the people can afford when they only earn $1 or $2 per day. But at the same time, there is no infrastructure, there is no way to deal with it. And even if it can be recycled as a monoplastic, the value of the material contained in a small sachet would never justify the labor to collect and process it. So then, and this of course has caused quite a bit of turbulence, and then the people started saying, okay, look, we switch to paper, we switch to compostable polymers, or we switch to the reusables or refillables, and I mean, and it went in a different direction. And at the same time, of course, people will also start saying that okay, look, we can shift from the multi-layer plastics to the monolayer plastics. We'll build the infrastructure, and it will work out. And eventually, that was the avenues which has emerged out of this report, which was published. And many brand owners made a commitment that yes, all of our packaging will be either recyclable, compostable, or reusable by 2025. In the beginning, it was a full of the ambition, and everybody saying yes, we have to do it because we have pledged to it. But what came evident after several years is yes, you can switch to the from the non-recyclable plastics like PET, let's say polyester, polyolefin structures, to the monopolyolefin structures. And yes, you can switch some formats to paper, and yes, you can use a compostable packaging. But in many cases, that is not changing the behavior of people. It's still ending up in the environment, and it doesn't really matter, even if for instance, compostable packaging is ending up in the environment. It's not always going to degrade, because depending if it's a marine environment, sweetwater environment, or if it's a landfill. In landfills, there is nothing will happen with the paper. Maybe you have heard the story. It's I think in a beginning of the 2000s, they found a landfill next to the paper mill, and they just excavated paper, and they've been recycling it, and it was one of the best papers which was there, because nothing has happened with the paper in the landfill. But yeah, coming back to what is happening now with desire for a sustainable packaging, I think people have also been faced, especially after the COVID, with the increasing price of life, with the inflation. And of course, if you have to switch to the alternative packaging, is going to be more expensive. And at the same time, if you just have a paper versus plastic, why would you pick the paper over it? Because plastic is less expensive and better functioning, and that's normally where the incentivization from the legislation should kick in. But unfortunately, it didn't work out. So of course, there was an effort with regards to the SUPD in Europe, which has replaced certain items like a styrofoam or the earbuds, which were then with the plastic. Now it's with the paper or wooden ones, but it hasn't brought a major change, because each of the European Union countries has a freedom how they're going to interpret it and what kind of financial incentivization they will put it again. So you could see that in some countries where they put like a 10 cents per coffee cup or 25 cents per takeaway meal if you are not using a plastic free. It has brought the change. So there was a shift, for instance, to the molded pulp. But in the countries where they just place the logo, okay, it contains the plastic, people were still tending to select a less expensive option. And then also, I think from the political perspective, yes, you can ban, let's say, plastics, non-recyclable plastics to be more precise, but it's not so that the economics is ready to face with the consequences of significantly increasing pricing of the commodity items. Because if you are talking about organic chocolate, coffee, some other premium products, there you can switch to the packaging, which would be 2 or 3 times more expensive. But if you are thinking about the a flour, for instance, or the loaf of bread, or something which is very commoditized, which especially the most vulnerable shares of the population are depending with a low income, and you suddenly switch to the paper, but the product becomes 20 or 30% more expensive, would they be happy to see paper there, or they would be more unhappy about increased price of the product? And that's something which you have to balance when you are switching to the sustainable packaging. So you either have to offer the similar cost, or you can rely a little bit on the incentivization, which is coming from the legislation, but overall it shouldn't lead to the increase for the purchasing price for the customer. And how to get there, I don't know. But for premium products, I would say we have all freedom to play, because there you can build the whole branding strategy based on the packaging as well.
Great. I'm going to make a switch and let's switch to India.
Mhm.
You coming to Pakka, and of course, we got to spend time and work together, and that experience. And of course, just for the listeners, part of our negotiation was that Alexey has to be able to buy a bullet motorcycle and take many trips on that. So, what
Mm.
was it that attracted you to India? And I know you have a deep kind of connection with the country, and even in our recent conversation, it kind of came
Mm.
up.
Mm.
And then, of course, the challenges that you faced when you were in India.
Well, before I went to work with you, I've also been visiting India as a tourist, and I think the thing which attracted me so much to India, it's actually, maybe it's an overestimation, but I think it's the most free country in the world, at least for me as a foreigner, because I'm not bound by any sort of family restrictions or religion related restrictions, or any other ones. But when you come to India, and it was still the case, and I think it still is the case, you see that there are so many things are not going how you expect them to go, for instance, in Europe. Because in Europe, you have a very well-defined sort of way of thinking. Okay, I'm going to the train station. I have to go to the track 4. It arrives in 10 minutes. Okay, I have a 5 minutes to buy coffee, and then I be there, and I go to my seat, which is a 21 by the window. But it causes actually quite a bit of stress, because you have to behave in a certain way. But when you come to India, and you see so much of the you can call it chaos, but there is an order in it as well. But you see so many things going like they're not supposed to go, or you're not used to go. You realize that you cannot be in control. I mean, you can be in control to get to your train in Europe 5 minutes before the departure. But here, okay, if you meant to leave by train somewhere, you will leave it tomorrow, today, doesn't matter. But things will happen, and when you sort of release this control, it's a very liberating feeling that there are certain things which you can influence, but there are certain things which are out of the circle of your influence, and to accept this for me was much easier in India, and that's why I like it so much. For me, there is as much freedom as you're ready to take, and that's what attracts me in this country.
Okay. And the second part of the question, as in what did you kind of enjoy, and what ultimately you felt that, okay, this is not your cup of tea?
Well, it's definitely the food. Food in India is amazing. I mean, and especially the whole variety which you have from the north to south, from east to west, and I mean, it's also, you see that the people despite not having much, they're happy, and there is more decency in let's say in having a low income, or being not like everyone, because there is also a certain tradition of the sadhus. There is a certain tradition of digambras and giants, etc. So it's not like if you are not owning much, or you don't care about materialistic things, there is something wrong with you. And this is quite interesting to observe, because in Western society, this is okay. There is also the monastic tradition, but it's not as active to the present moment as of now. But and that was also quite eye-opening and interesting. But on things which are, I would say, a bit difficult sometimes to accept. Okay, one can say it's because there are a lot of trash on the streets. You see sometimes the cows eating the plastic bags, but it's there are many reasons to it, and it's not always about people. In my opinion, it's also because of lack of the systems. And if you're thinking, before there was a perfect solutions like the school huts for coffee, etc., but then it was replaced with maybe something which was not well thought on how it will integrate in the system, and coupled with the rapid population growth, it led to these things. And sometimes, and I think it's also very much depending on the state, you could see that there is a little bit maybe harsh relationship. So what I, for instance, have seen that in UP, in Uttar Pradesh, there is a little bit more like this. I would call it maybe a barking style of the communication, comparing to the Himachal, or comparing to the Karnataka, for instance. And to see also this diversity, that there are so many states, and eventually the states are so much different when it comes to their people, also culinary tradition. But at the same time, there is still some sort of a common idea, which I think coming through the religion, it was pretty fascinating.
And let's drill down to Pakka experience. Things that we, of course, you being here just for I would say even for a very short
Mm,
time, had a deep impact on Pakka and the way we
mm,
thought about things, the way we did our research, our own team, which still keeps in touch with you and, talks to you and takes guidance. And a lot of them chose you as their personal mentor. So you had a deep impact on Pakka. But let's
mm,
talk about it the other way, the things that you learned by switching from Nestle to Pakka is a
mm,
big shift, right? In terms of size, culture, products, in all
mm.
sorts of ways. So what were the things that you were proud of in terms of contribution, and what were the challenges that you ended up facing, and obviously in the end deciding to go back to Europe?
You mean apart from this refrigerator, which you always reminded me, which I carried in the lap? So that was by far, I think,
That's
the
a good
biggest.
story. You have to tell the story to the listeners. Go ahead.
Well,
That
I
shows you a
think
bit of
you
India.
I think you remember it in a better way than me, because for me it was just a heavy work. But yeah, so there was this once we needed to get a refrigerator for samples, and I think they deliver it just next to the lab, and okay, there is objective. We have to get it into the lab, but it's too big, and normally you need. But once again, in Europe, there is a special person who will come and do it, and they deliver. You sign the paper, delivered. Okay, fine. But here, you have to solve the problem. So okay, they just found the guy, and we carried it inside. But it just a general reflection of the learnings which I get in Pakka, in my opinion. Because what I have learned, that, so if you want to do something, you cannot expect that there is people who will do it for you. So sometimes you have to just go and do it. If you need something, go build it. Get the raw materials. And just do it. And that is, of course, a little bit different, maybe in the previous experiences which I had, where there was, the well-defined structure. If you need to do that, you use this program. If you need to order something, you get to this person, and then it gets delivered. So here, some things were working still. Not to say it was and I think few systems worked fairly well, but sometimes it really pushed me to get out of the comfort zone and do something myself. And of course, also sometimes looking how the things are implemented, like in terms of the the laboratory protocols or the way of working. There were quite a bit of inefficiencies, and I tried to change it also with my team. And this kind of experience of little bit breaking the established routine, and sometimes getting some looks like for coming into the shorts to work, etc. But come on, it's 35 degrees. How you would expect to be in the long pants there? So yeah, but it was great. It was great, and of course, the whole how say the entourage, the environment where you have the operating agenda, starting first with the prayer, and that you have the puja when you do the shutdown and you start the machine. I think it's called the juggernaut. So you do the puja, and each machine apparently has its own. That was pretty cool as well, because once again it says, okay, there is a certain things which are in your control, but things which are out of your control, then you do the puja for it, and it works. So
That is true. That's what they say, right? Once you're on the Indian roads, you know there is God. There is no belief or no belief. You know that's the only way the
mm.
Indian traffic survives. So it's like
I
that
have
sort
a
of an
different
idea.
theory. I
Okay,
have
go
a more
ahead.
materialistic theory, because again, in the West, we are forced to look in front of us, but we're also forced to check the mirrors. But in India, you only focus what is in front of you. And if everybody is focusing on what is happening in front of them, things are working beautifully. And I think that's how it actually functions in city. Because in India, I never use my mirrors. Because whenever I started to get to use my mirrors, I was getting in trouble. It's like when I take also this car from the farm and I run into the ditch. That was when I when I use the mirrors. So I learned, just look in front of you, and then it works. But yeah, I think the divine is present there on the roads too.
No, that's definitely a good analogy. So the other thing, of course, for the listeners, Alexei and I also lived on the same farming commune, and we spent a lot of time together. One of the things that was evident, Alexei, was the scientist in you was always alive. So, like we mentioned right in the beginning, the master of kvass. So
Mhm.
that's the other side of Alexei we got to experience, where there was a lot of concoctions being made and experimented with. So thank you again, officially online. Thank you for treating us to so much of kvass. And kvass is like a Russian kombucha, I would say. Is that a good definition?
Well, it's pan-Slavic. I would say it's not only Russian, but it's basically a fermented bread beverage. So, which is mildly alcoholic, like point half percent of alcohol, but it's just a byproduct. But yes, there are different kind of kvass, but we are just missing a little bit of the fizziness, so to say. And okay, we thought, why not to do it? Because it's something, at least I remember when I was a kid, you usually really like when the weather is hot. And when the monsoon was approaching, that was also one of the remedies which we decided to use. So it worked
And
out
the other
pretty well.
thing, and the other part of your personality that was so fascinating was the competitiveness in you. And, so that was ever evident in terms of whether you were playing badminton or
Mhm.
eating chilies or going for a run. So where is it at? Where does that come from and how does it serve you well?
Well, I don't know. I just think it's fun to compete, and and I like to win. I don't like to lose. I mean, and I still unfortunately it's the case. So I try to engage in the competitions where there are good chances to win. And I think with the Chilis, it's only about your ability to suffer, and this I have a quite on a good level. The suffering ability by default, and many Russian people is on the high level. And yeah, and when it comes to the running, it's also like I don't know. Competing is fun because it's also about the emotions which you generate at the end. It's sharing the fun with the person with whom you're competing, and at the end, it's also a good ability to improve yourself. Because if you see that someone is doing better, you start to ask yourself, why can't I do the same? So competition is nice, I would say, but it's important also know where your boundaries. And I think with age, I start to see that some things I better, some competitions better not to engage to.
About time, huh? So for the listeners, so Alexei actually carried a set of 16 levels of spice or chili. and he was always experimenting how high he could go. 16 could apparently kill you. So I think, Alex, you were at 8 and I was maybe at 3 or 4. So maybe you went higher after that, but that was that
No, I think we went to the
gradation of.
14.
You did?
We went to the
Okay.
14, yeah, when I was still in India, yeah.
Yeah, and of course,
But
our friend
I'm
Srinivas started with 16.
yeah. But it's still I still have this crave for the spicy food, because for me, if the food is not spicy, I mean, what's the point? You don't get the full experience.
Amazing. So let's switch back to Europe. Of course, you go to Nestlé,
Yeah,
you do a different role, but then you switch to and that's a very
yeah.
different kind of company. So talk to us more about that experience from the lens of
Mhm.
sustainable packaging, and what kind of contribution were you able to make there?
At some point when I was working at Nestle, what we have done, we've been working on the developing of the new materials. Of course, Nestle is not making packaging, so we have to work with the partners, with the suppliers, and we have come up with a couple of pretty good concepts. But it was difficult then to find a way to produce it at scale, because even if you are a big company, then maybe you only need like a 50 tons, and of course you sort of arrange all of the production schedule, but and supply chain, but to produce it at scale and means also at the right cost, it was always a little bit of a question of the chicken egg, give me the volumes, I'll give you the cost and so on. And at that time I thought, okay, look, maybe I can try to look on this alternative paper packaging materials with a better functionality, slightly from the different angle. Learn what kind of challenges are being faced by manufacturers of these materials rather by the brands. Because as a brand, it's clear you have your product. It has a certain water activity. It has a certain protection level which you need to provide, so that it comes to the customer in a food safe form and a good taste characteristics, in a good taste, so to say, or organoleptic. That is the right word. So organoleptically pleasing, and then you just find the material, and in many cases you find the material and then you start to compare the price, and you are usually then selecting the plastics because they're less expensive and they're well performing. But as a manufacturer, you have more choices, I would say, because you, especially if you're making paper, or in this case it was a paper board. It was a bit of a paper business, but mainly it was about the paper board. Of course, you have to make something which is at least 10, 20, 30,000 tons, and you cannot rely on the super niche application. So you have to come up with relatively commoditized products, and to look on it from this perspective was definitely a valuable experience. Plus, at the end, I was a paper engineer, which has worked very little into the paper industry. I was always around, but not in the paper industry. And of course, it was good to learn. On top of that, it was also the Meyermanhof is one of the biggest recyclers in Europe. And to see also the recycled side, or recycled angle of the paper industry was quite interesting. So overall, it was just the decision to leave from Nestle was based on the maybe ability to change the things, to help to the manufacturers to get this view on what kind of products brand owners are required. But at the same time, it was also a learning, I'll say, going back to school for me for paper making, board making, and learning the recycled side of the paper business, which is biggest part, if you think by the volume now in the world.
And then you switch to something which is totally unique, and your current work with Capsule in, and talk to us a little more about the organization, what it does, and what attracted you to come and lead the cellulose function there.
So I started in Capsule back in September. So it's a relatively small company of around 30 people, but which produces 4 billion capsules. So it's quite big number, and of course capsules are consumed quite rapidly, and there are a lot of units on the market. But we are making the capsules which are made from the aluminium, We are making still a minor share of the PP plastics with a specific in-mold labeling technology. And a couple of years ago, we also have launched the home compostable better oxygen better capsule, which is also on the market using also the specific in-mold labeling technology, and now working hard on the bringing up the paper, or let's say the cellulose or pulp alternative, which is a bit challenging because even though there is one product on the market, but to get all of the performances right in terms of the because in the Nespresso machine you have a roughly 19 bars of pressure, 95 degrees water. It's for a short period of time, less than a minute, but to make pulp withstand these conditions without bursting, without changing the dimensions, it's fairly difficult to start with because it's still hydrophilic material. What can you do with it? And on the second hand, you still need to provide a barrier to the coffee because coffee or roasting ground coffee is one of the most challenging products. So you have to think how you can make it comparable to the aluminium. And I would say if you think about the compostable materials, you well know that the oxygen barrier, I wouldn't say it's easy peasy, but it's possible, can be done, and also not necessarily at a big cost. But the water vapor barrier is you either compostable or you have a water vapor barrier. There is nothing in between, so to say. And this is of course also quite a challenge. And what maybe to join Capsulin, basically when I was working in the MM, there was quite a few projects which have been finalized. So we have commissioned this molded pulp production in Poland. And also what I have seen, and that's what we discussed in the previous part of this conversation, that the momentum in sustainability is starting to get down. So meaning it's more or less boils down to the cost competition, whatever is more affordable in terms of the total cost of the ownership, which then of course includes the extended producer responsibility fees, which includes any sort of plastic taxes or SUPD fees would be selected, but in many cases it's still a plastic material. And at least in Europe, you have to wait until the further provisions of the PPWR will come in, which are coming then in 2030 with the recyclability grades, and in 2035 with recycled at scale criteria. And only this could bring a major shift in terms of the demand for a fiber-based packaging. So I said, look, let's maybe not try to make thousands and millions of tons of it, but let's look on the specific application. And I also, as I mentioned, this is a relatively small company, so I have met with the founder, and he just explained to me a little bit the mission, that they're also very much driven by the sustainability, and that they have launched this home compostable capsule, but there is also a big interest to develop a paper one. And I would say, look, very concrete objective with a very well-defined timeline. So I think it would be good to take a very concrete challenge without trying to, make big things, which are not necessary, where you just do things for the sake of doing without big hope for the result. And of course, also from the technical perspective, I think, yes, pulp is difficult, but if you think from the economical one, the bioplastics, they are not going to become very much affordable because there is quite a bit of the production steps. But if you think about the raw material, it's pulp is, below 1,000 euros, so it's actually less than the PP resins, for instance. So technically, you can make the paper capsules or pulp capsules be less expensive than the aluminium ones or even plastics ones, but you just need to find the right way to do it. So it was making sense to me, because in terms of the 3D objects or rigid packaging, it's a little bit different game comparing to the flexible packaging or to the paperboard, which is very much linked to the folding cartons. So yeah, that's so far it's been fascinating. It was a good ride, but what I have not taken in consideration, that's when you work in a small company, you have to work. And I got maybe a bit lazy during my last few years. So now it's learning how to work a lot again. So
Yeah, last time we met, that's what you told me, that you have to do all the coatings yourself. You are a lab hand again. You have to work with the materials yourself. So yeah, I guess that's always a good thing in the end.
No, no. I mean, you can get all help what is needed. You work a lot with external partners, but it's a little bit similar to what I mentioned about my experience in Pakka. That's, look, if you have to do something, you just go and do it. Nobody will come and do it instead of you. So
We would like to take a minute to thank our sponsors. Good Garbage is sponsored by Pakka, a family of brands that produces compostable packaging and works to implement regenerative solutions. Pakka's new project is to bring compostable food serviceware and food carry products to the North American marketplace. Learn more at pakka.com. Now back to the conversation.
Okay, so you mentioned in passing about water vapor transmission or the moisture barrier. So what makes it so difficult to tackle, Alexey, that you even said that you can have one. Either you have compostability or you have the water vapor barrier. So why is it? Talk to us more scientifically and structurally. What makes it so tough to crack? Why can we not crack it in a biodegradable or a compostable structure?
water vapor is a polar substance because you have oxygen and two hydrogens, and there is a certain charge inequality between them. So it's a polar substance. And if you think about the permeation or permeability or the barrier, so essentially it's about the dissolution ability of the substance which is trying to permeate through something, its ability to dissolve in the media. In our case, it would be polymer, for instance. And it's also about the ability to diffuse, and this is a little bit linked to the molecular weight. And essentially, if you have a polar substance like water vapor, the best way to stop it would be a non-polar substance like polyethylene or polyolefin, because it has basically carbon, 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 and nothing else. So that's how it works. If you want to have a barrier to the polar substance, you have to have a non-polar structure, ideally also with a high crystallinity because it densifies it. And if you want to have a barrier against the non-polar substance, like an oxygen, which is just OO, so it's quite balanced structure, then you need to have something which is polar, like a polyvinyl alcohol or cellulose actually would be a good oxygen barrier if you think about the nano or microfibrillated cellulose. So that's more or less the basic explanation. But why it is not possible to have something which is non-polar and compostable? It's also quite simple, because if you will start to add because in order to get composted or biodegraded, you have to be accessible to the water. And if you think about the carbon, 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 water cannot do anything without with this sort of polymeric chain, or it takes a lot of time. But if you have, for instance, the PLA or polyhydroxyalkanoates, or if you have, PBAT, polybutylene succinate, if you look on the chemical structure of these polymers, it has a lot of the polar groups. It has carboxylic acid groups. It may have also some hydroxyl groups. And this is the sites where the water, and then respectively, if you go a little bit to the macro scale, the enzymes or bacteria which are in this water, they can start to interact with this polymer and eventually degrade it. So, but once you start to introduce the polar substances in the chain of your polymer, then your water vapor barrier goes down because, or actually, yeah, your water vapor barriers go down because then the solubility of the water vapor in this polymeric matrix becomes higher, and then it's only about the Henry law and Fick law to calculate the permeation. There are some options, like if you would have an inorganic substance, and that's why, for instance, there are some options like when you would have the aluminium oxide metallization or silicon oxide on the compostable polymer, it may offer you a good water vapor barrier, but it would be only because of this inorganic layer. And one need to remember that it's very thin. We are talking about the nanometers. So it will give you a good barrier on a flat material, but once you start to interact it, it may bring some challenges and it may be gone. So that's from the chemistry or physics point of view, how to explain why it's difficult to have something compostable and good water vapor barrier. There are also waxes, and some biowaxes can give you a decent water vapor barrier, but biowaxes it's not like they are also easily degraded, but they're also having a little bit of this polar groups in it, which eventually helps it. Plus, it's a low molecular weight compound, so it's a bit easier to degrade than polymers. But with biowaxes, for instance, you will never get a heat solubility. So heat solubility is something also which is difficult to obtain in some cases.
So, how does nature solve it? Let me give you a few examples, like a coconut. Of course, it's a bigger substance, there is layers, etc. Our own kidneys, we are also retaining a lot of water, and we, of course, are being able to retain it in one place. I'm also inspired by, I don't know if you know, the water spider that makes a whole web underwater, but keeps a gas inside, and it procreates, it eats everything it does on the web. And as far as I know, with my very limited understanding, it's all amino acids. It's a protein chain that it builds, and
Yep.
it is able to protect it. So there is obviously substances, and of course then there are minerals, like you said, like an eggshell. Okay, it's a little bit of a viscous liquid, but then again it's very, very densely packed, and it doesn't go away. And various crustaceans again will be great examples of that. So if we imagine nature being able to do it with certain structures which are not which are many times may not be inorganic, so then how is nature solving it compared to what we are trying to do?
But it's a little bit difficult question to answer it in a short period of time and not to lose your thought in between. But what I wanted to say is that nature has time. It's not necessary in the rush. So it doesn't have an aim to deliver roasted ground coffee from Ethiopia to the people in Japan by tomorrow, and that it still can be stored for 3 years and it will be good after that. So nature doesn't have the same. So that puts a threshold in terms of the effort to a little bit lower plank, so to say. And of course, the examples which we have provided, yes, coconut. It has many layers for sure. It has a liquid inside, but then it has also the pulp, which is sort of impregnated also with the fat, which is actually the first layer of protection. So what protects the liquid is the pulp, which is impregnated with the fat, because fat is hydrophobic. Once again, a non-polar substance, it protects the liquid inside, and then you have a hard shell, which is more for the mechanical protection. For kidney, it's a little bit easy. It's very easy to keep water in the kidneys because inside of your body, basically there is no difference. You have a water outside, you have water inside. So we are full of water, so there is not so much desire for the water from kidney to escape out from the body. But what I'm trying to say, the nature is very smart in selecting the things which it wants to protect. So if you would think, for instance, walnut, another typical example, you have the walnut shell, you have also the layer in between, and then you have the skin of the nut, and then you have, let's say, the flesh of the nut. And if you walnut itself could be good one for 1 year. If you take it out from the hard shell and you will still keep a skin on it, it would be fine for maybe 1 month. After this, it will get rancid. But if you will grind, it will get rancid in 1 or 2 days, because then it's also about the surface area. So it gives you this multi layers of the protection, which somehow can be mimicked also in the packaging. You could call it a barrier shift, or when you sort of distribute your barrier between the primary packaging or secondary packaging. What is also can be done, there is some work can be done on the product. So maybe you have seen also there is, for instance, a coffee bean in Switzerland. What they do, they compress the coffee balls. So they, instead of having a loose coffee powder, they compress it, and that it of course also reducing the surface area, so it reduces the oxidation rate. So you can sort of play on different levels. You can make your product to be less sensitive. Basically, try to do the same thing as the skin before the hard shell on the walnut. Then you could have your primary packaging and your secondary packaging. So I think we're already doing it, but once again, it's a completely different mindset between the people who live on average 85 years and nature, which is not supposedly caring about how much is going to live. So that's why approach is also different. It's mindset, I think, the problem.
you mentioned in between, and we were talking, I think, even yesterday about fatty acids and chromatography. So, what do you think of that principle? And I'm kind of correlating it to what you were talking about in terms of the coconut, that there is a fatty kind of layer, fat layer that is in between. And of course, we have a common friend who's trying to work
Mm,
with fatty acids and find a
mm.
way to impinge it on the surface. So, what is your take on that? Do you think that might find some solutions?
Well, if you're talking about grafting of the fatty acids, it's more or less about the changing the surface energy, because we are not talking about creating a continuous layer of it. So whatever is related to the surface tension, like the water repellents, fat repellents, it can be controlled, but you do not have the ultimate physical barrier to the penetration. So yes, it can address some topics, but it's essentially, you can either do it through the, for instance, through the chromatogeny, through the grafting, or you can put a layer of wax on the surface, and the effects would be quite similar, but just with the wax you also have a physical barrier, for instance. So it's one way, and it's really a way how to change something without altering the structure, just by chemically modifying the surface energy to reduce the wetting. But it's one of the approaches among many, and it's not necessary can be combined and with the things. But some other things can be combined, like in a multi-layer barriers, where you can do the pre-coat, and you do your oxygen barriers, and you do your water vapor barrier, heat soluble layer, etc. But chromatogeny is quite a specific technology. I would say, to comment further on it.
So, if you were to look at, of course, I come from a very little understanding. So, if you were to look in nature, will you find other methodologies that might be something that excite you in terms of creating a better water vapor barrier? And I'm talking from my perspective, it was examples of products, but for you, it may be, the integration of systems or materials or things like that.
It's a bit difficult to say, because I already gave out all good examples, like with the walnut and everything, and now to come up with something new is a bit of a challenge. But I would say it is it from the examples from nature, and I already said it, I can clearly see there is a complete different approach to the protection. It's not so much about the efficiency of the production. It's not so much about doing it within the short of period of time, or least expensive. You just do it because you can, and nature has essentially evolved itself in order to be able to do it. And it didn't take like 20 years, but it take millions of years. So we're comparing essentially incomparable, and we, as a short-lived species, I think sometimes we are a little bit in the rush to do things, rather than to think about why we are doing this things. But indeed, we can either take the best from the nature, like we've been doing already for ages, like with the biowaxes, and use it with the coatings. There are also some, you mentioned proteins, so there is quite some interesting work going on the proteins, because the proteins have several layers of structure. So there is a primary structure, secondary, and tertiary structure, and in some cases even quaternary. And then by controlling the structures, you actually can change the properties of the proteins quite in a large scale. And there are a couple of startups looking into this. I think one example is Example, for instance, from the UK. So they are looking specifically into the proteins, and there are more. And for sure, we can learn something from the nature. But my doubt here is whether it would be what we are looking for, because we are looking for something which may be done by nature, but it simply cannot be accepted because of the cost, or because we are too impatient.
So if we look at, again, just taking it forward a little bit, so of course, both of us come from the cellulosic kind of discipline.
Mm.
So at least my mind goes more towards, okay, how do we do it with a cellulosic structure? And again, like you were mentioning, in nature, there is gradients, whether it's a protein structure or even a cellulose structure. If you take a lotus leaf, it's a lot to do with, how the fibers are bound by different sizes, and it can go to a nano level right on top, so that it kind of protects what is from the water, apart from the nodules and the physiology part of it. So if you look at like if you skip the cellulose, that okay, we need to do everything from paper, and you and I both know that won't be feasible. There will have to be other materials. Are there ideas out there which are trying to solve it through a monolayer idea? Because that also helps in terms of course, people are trying to do it from BOPP and stuff like that, but then you still have a challenge overall, and you still have a challenge at least from the source aspect in terms of it's still fossil fuel derived. Are you in touch with some ideas that maybe a monolayer structure with a gradient or something else?
Glass, metal, and ceramics. Been existent for ages. Good stuff. But there are, I mean, the reasons why we switch from the glass, metal, and ceramics for convenience, for the cost, for ability to distribute it, for the supply chain losses, but not for recyclability or poor better. You know, from time to time they found the ship crashes from 300-400 years ago, and they found the beautiful bottles of cognac or champagne, or which are still drinkable. So it's a good better. So yeah, I mean, I have nothing much to add to it because essentially there are already, I would say, more or less a trouble-free, if you can say so, inorganic materials which can be used, but we shifted away from them for different reasons. Because if you think how it was 150, 200 years ago, even paper was not used as a packaging. It was used as a more of a reading media. Maybe you have a bit of a parchment or something, but everything was in a reusable, refillable packaging. It had its own challenges, but it was working. But also then the world population was less than 1 billion. So now we are at 8 and still growing. So soon it will stop, but we are still growing. So of course, different problems require different problems. But to have something as efficient as glass, and eventually the multi-layer plastics was the answer to the problem, how to make it efficient and affordable. And I'm not sure if we are ready to reverse back to the glass and metal, because only developed economies can afford it, and it's also significant inconveniences for people.
Those are
So,
great examples. Thank you for that. It didn't strike me. And in fact, recently I was reading a book which was based on, 6 materials that made the world. And all three that you mentioned were in there: ceramics, glass, and metal. And of course, then petroleum polymers came in, etc. And, those who
and
followed
paper
this.
should be there for sure,
Of course,
because
cellulose
if we,
was there, of course, as well. Yeah.
yeah.
So that's interesting. Okay, so taking a little switch. So there are so many new materials, Alexei, that you and I see every
Mm,
day. It could be a seaweed based polymer, it could be a PLA, it could be a
mm,
PHA, it could be, Zampla is something you talked about, protein based,
mm,
crustacean, kind of
mm.
chitin based, etc.,
Yeah.
etc., etc. So, are there materials that you are truly excited to see and think that, okay, this is something I want to watch out for in terms of performance, price, and scale? What would be those few materials that you would be excited about?
I mean, look, like we mentioned, the chitin, chitosan, polysaccharides from the seaweed, the alginates, carrageenans, etc. These are all known substances with well-described properties, with well-described structures. You know what you can get from it and what you cannot get from it. So take, for instance, the alginates. Good grease barrier, possible oxygen barrier, heat solubility, water vapor barrier. I mean, yes, you can combine it with different ways, but look, we cannot do better than what polymer can do. So there is one excellent polymer. It's called PVDC, polyvinylene dichloride. That's one of the few polymers which has an excellent water vapor barrier and excellent oxygen barrier properties, because it is non-polar, but at the same time it's highly crystalline. And just by looking on the polymeric structure or on the chemical composition, you can understand what this substance will provide to you. What I'm getting more excited about is not about this isolated, polymers or substances or coatings. It's really about how the people can tailor it for efficient application. Because one thing, yes, alginate, excellent, from the seaweed. It gives you grease barrier, so let's put it on paper. But then what complicates is it's when you have a 10% solution, the viscosity is such it's you you cannot even steer it anymore. So it's so thick, and how to apply it then? So then you have to dilute it to the 1%. But is it logical to evaporate this much water? So for me, the more of the innovation will come in how to combine the things in an efficient way. And if you think specifically about the barrier, for me, it's still about the inorganic layers. Of course, we have now the standard metallization, we have the xyloglucan, which are a little bit more advanced and transparent, but there are also many startups now working on the atomic layer deposition for the fiber-based materials. There is one startup in Canada, one startup in France, and this is interesting because it do not require necessary to have a vacuum, so it could be done in the atmospheric pressure. And ALD is more; it's not a line of the side deposition, but it also includes the chemical bonding. So it's like a bit of the chromatogeny, but you actually do it with the silicon, where you can build a good inorganic layer, and it's more selective. So that's maybe, if you think about the barriers, this ALD is maybe one thing which could have a potential to get both of the swords, compostability, recyclability, and high water vapor and oxygen barrier. For the rest, everything can be learned from the structure. There are no miracles, except for the
So,
ones which happen in India.
of course. So if you look at, like, we are producing whatever upwards of 500 million tons of petroleum polymers. What do you think the shift will be? Because ultimately, like, it is a finite resource. At some point, we will, as humanity, we will have to move away from it. It may be 50, 100 years down. That's fine, but that's not that far. So how do you think, do you just think that people will keep evolving solutions as they are pushed against the wall? Or do you see something that is honestly going to scale to be able to get to millions of tons and not talk about, you're right. Even when I talk to the players in the alginate space, they're still talking about 5,000 and 10,000 tons a year, which is very, very little. So is there something apart from cellulose as well, that you think that can be scaled?
There were big hopes on the PHA, and it's still showing some hopes because the PHA is quite flexible in terms of whether you use a PHBH, PHBA, or whatever kind of the polyhydroxyalkanate. You can alter the properties quite on a broad scale when it comes to the heat solubility, to the water vapor and oxygen barrier. And I think this seemed to be still scaling up. There were quite a few collapses as well. So there's a few companies which went to the PHA, they went into the bankruptcy and so on. But in general, there is a still movement there. So that, I think, is the one substance to look specifically if you need to have the certain level of the heat solubility, and also when you need to tick all of the boxes for a compostability in all of the environments. There are also other model polyesters which are being developed. So basically, all sort of blends of the PBAT, PLA, PBS, PBSA with a different degree of polymerizations branching, and that's also, I would say, at least they're solving the issues when it comes to heat solubility and to the liquid water barrier. But if you think about the replacement for the fossil plastics, I'm a little bit not so much hopeful, at least when it comes to the recycling of the polyolefins. No doubt that you can recycle pure PP or pure P back into the PE and PP. That's for sure, whether it's mechanical recycling or even chemical recycling. But when you start to think about the packaging, where say you have a 30 micron of BOPP, on top you would have 4 micron of the printing inks and 2-3 microns of the varnish, which not necessary of the polyolefinic nature. And you also may have actually 2 layers within the PP1, which would have maybe the skin layer with the ionomer, and the other one would be a BOPP. And when you put a structure which is already 20% different to the base material, you cannot hope to get 80% of the target material. So there would be some losses. So for me, the question is whether we would be able ever to have a recycled plastics which are good enough to be used again in direct food contact, and what would be the yield. It is possible, but I don't know whether it would be 50% yield, 70% yield, 80% yield, because there are practically No chemical recycling processes out there, maybe except for the glass, which basically you break it and then you remelt it. But it's I'm not sure if it can be considered mechanical or chemical recycling because it requires a melting stage. But in that sense, I don't know what will come to replace it. But we also need to think that now when the most of the petroleum consumption or the oil consumption was for the transportation and energy. And now switching to the EVs, we still have plenty of oil to be used for polymers for 1,000 years to come. And maybe we can just incinerate it with the energy recovery. I don't know. I mean, I'm just thinking, look, if you have enough of it now because you don't use it for cars, and you can make you can process it with a green energy, and you can incinerate, you can recover, you can capture the CO2. Do you really need to recycle plastics? I don't know.
That's definitely what Singapore government would agree with. They tend to burn
And
everything
Japan
and
as well,
yeah.
Japan as well. No, I'm just and at the end you still can make the plastics like PE and PP. You can make it also from the bio based. So I don't know. It's like the same topic with the nuclear energy. I mean, nuclear energy could possess some dangers, but at the same time, it's one of the great achievements of the humanity because yes, there are nuclear reactions in the stars, but we are able somehow to reproduce it and use it for energy. So in terms of the salts and the, whether we should be proud of it, yes, definitely. But at the same time, we didn't manage to contain it in some cases, and it led to some accidents. But whether we should say no, or whether we should rather develop thorium-based reactors, which are much safer than the uranium or polonium-based. That's one thing. And the safer plastics, it's also something which it doesn't exist in nature. It's a merit of the human race that we have come up with the substances which are so good, but we just haven't thought about what could happen with them. So maybe we should rather focus on this one and not try to reinvent the wheel by, as I said, it's all about the polarity and non-polarity. But for me, of course, there is still enough work to be done with paper and cellulose or other things. But it's a philosophical debate, so I don't know. But
No,
plastics
it's
are
an
good.
interesting.
They do the
Yeah.
job. They do the job.
Yeah. And it's an interesting perspective worth thinking about. Let me take you towards. I'm noticing that you're doing more and more on the propagation and policy space. So how do you see the SUPD, what is what PPWR ideas
Now,
that are being propagated in Europe? What is your take on that direction?
ambition is good. Ambition is good. Implementation, at least if you look on the SUPD, has maybe been not that efficient. So because I'm not sure to which extent you're familiar with the single-use plastic directive, but once again, they looked what is present on the European beaches in terms of the waste, and they just decide, okay, with these items we do this measure. So it's bans in some cases where there are easily alternatives available, like a plastic handles for the balloons, earbuds, and things like this. Then there is some restriction in consumption. It's more for snacks packaging, for coffee cups, etc. And for something, it's awareness measure. But they say, okay, this is a set of the things what you can do, but you 27 or 26 now countries of the European Union, you have to decide how you're going to implement it and how you're going to control it. Some countries went with the bans, and it was banned. In some cases, it is was so that the materials which are not compliant with the SUPD, they've been taxed per ton. So you pay, let's say, extra 500 euros per ton of the material, but you still can use it. In some cases, you've been asked to pay an SUPD tax per item. So let's say you pay per each cup, per each container. So 10 cents or 25 cents, and that of course would translate maybe to 25,000 euro per ton, and that makes a lot of difference. But in some countries nothing happened at all, and this is an unfortunate situation. Of course, what's now going on, they're now assessing what was the impact of the SUPD on the reduction and the consumption, and there is also a public consultation going on, so there is a hope that it will harmonize. But so far as it is a directive, there is a freedom in terms of how to interpret it. With packaging and packaging waste regulation, as it is a regulation, and there is a big difference between regulation and directive in European Union, it really says, okay, you have to do this and that and that. You have to reduce the consumption, and from this year, you have to have at least this much of the recyclability. From that year, it should be recycled at scale. And recycled at scale, it means at least 55%. But what 55% means is that you have to have at least 82% of the collection. Then you have to have 82% of the sorting. So basically from 82% you collect, you have to sort properly 82%. And then you need still to have the 82% yield and the recycling. So only if you multiply the things, you get to this 55%, which is not so much obvious, because recycling is the easier part, but to get the 82% collection and 82% sorting is quite tricky one. And of course, with the packaging and packaging waste regulation, there is quite a good hope that it will work better, but it still leaves some room for the countries to decide how much they would charge, for instance, for the in-compliance or for the poor recyclability, because there would be also this eco-modulation. So depending on whether it's 95% recyclable, 90 or 80% recyclable, you would pay a different fee. But what would be the differentiation in these fees? We do not yet know, and that leaves a lot of room to guess, and they should come in 2028 with a delegated acts. But still, each and every country will be able to decide which fee to select.
It's definitely complex. Okay, taking the conversation towards closure, I'm noticing that you're spending a lot of time in kind of collaborating, teaching, conducting workshops in terms of barrier chemistry, building a cohort. These are all things that you don't have to do for your job, right? So these are things that are clearly coming from a place of passion, desire, something that you need to do. So where is this coming from, and what makes you spend so much energy on ensuring that you keep at it?
I mean, yeah, we've been organizing a few courses, what we called a PhD course, or where we also invite the industry. So we did one in Finland, one in Slovenia, one in Sweden, and recently one in India. And there are several reasons why I'm involved in this. First of all, it's more about structuring and retention of your own knowledge. So you have learned something, but if you do not structure it properly in the form of slides or whatever, it will be gone eventually. It's a nature of humans. We cannot host all of the information in a good access all the time. Second, very selfish reason, I want to meet with good friends which I made during my track in the industry. And the usual case, if you go on the conference or the course or event which is organized by someone else, you meet maybe one of them. But it's much easier to involve them into one event, and you meet all together. So that's another reason of why we are doing it. And the third one is also, like, I have got a lot of knowledge, or I have learned a lot of things from the people who never asked much in the return. So I also feel there is a certain obligation to give it. If it's useful, people will come. If it's not useful, they will not come. So I'm not pushing people to consume it, but I think it's good to be able to give back also at some point. It makes you feel better. But so purely 3 egoistic reasons: knowledge retention, meeting with your friends, and feeling better yourself. So very egoistic reasons. And then, of course, specifically for India, it's just because I wanted to come to India.
All good reasons, I would say. Okay, so if you were to gaze in a crystal ball and look at 5 to 10 years hence, what would be the changes primarily, like the top kind of 3 or something that you would like to see in the next 10 odd years in terms of sustainable packaging?
I want to see less fluff around it, because there is a lot of, so in some cases there are too many words and not so many of the technical data sheets. I mean, not even about the greenwashing, because greenwashing it's more or less a consequence, but there is just, say, sometimes people are saying, yes, we have a great technology, great compostable product, what it can do. Yeah, maybe it can do this, maybe it can do that. But why we all wouldn't save our time and say, yeah, this is like this. Maybe you can get this. This is a beta which you can obtain at this thickness. That's it. We're not saying if it's going to work for this or that, because it's eventually upon the discretion of the people who are producing the products. But when they know what this material is offering, it's much easier to decide. Of course, it's a bit difficult in a space when we're talking about the coatings for paper, because depending how good or better your paper, your coating performance could be quite different. But there is pretty much nothing new on this planet or under this moon. We just reusing the same substances, maybe mixing it a little bit differently. So I see there should be maybe a little bit less of the secrecy around it, and a little bit less of the fluff. So say more direct information, easily accessible. Of course, some things I believe they should be confidential, like if you have a specific formulation, like for instance, when you make it to work in the specific coating process. But to say instead of saying, oh, it's a seaweed-based polymer, we are saying it's sodium alginate, or we are saying it's carbocarbogenone. I mean, why can't we say it? It's not like the people will steal it carbocarbogenone from you because it doesn't belong to you. It's coming from the sea. I mean, like what's the idea to hide it? It's your know-how is how you make this carbocarbogenone works. It's not to know that there is a carbocarbogenone which is existing. This I would like to see, and of course this will help to everyone to make more informed decision, and also maybe eventually to close the gap in the cost, because there would be a certain volume generated.
Anything else? I asked for 3, you gave me 2. More openness and lower the cost because of that collaboration and openness. Yeah, I'm happy with 2, but if you want to go one more, then I'm happy to take that too.
Yeah, and I think where we would see still quite a bit of happening is really on the 3D forming of pulp or paper, how you like it. Of course, what we see now is that the molded pulp is the standard wet molding is developing quite nicely. So there is more and more, and there is also the new machinery concepts, the energy consumption going drastically low and so on. But what we also see a lot of things going on the dry and different dry forming technologies, because what you see sometimes you can get to the density of pure cellulose by dry pressing of pulp. And that is, of course, fairly interesting, because when you get to the density of cellulose, you start to have an oxygen barrier. You also start to have an irreversible hornification, which could give you also a water resistance, not water vapor barrier, but water resistance. So there is quite a lot of things going on and being developed in this field. So meaning structurally and just through the compression of pulp, there may be quite a few interesting things coming in. Also area to look for, in my opinion.
Nice. Okay, my final question. What does good garbage mean to you?
Good garbage is something that you can turn to money, because I remember when I was a kid, I was collecting empty bottles, copper, other kind of metals, breaking them back, getting some money. That was a good garbage.
Thank you, Alexey. As always, this conversation with you has been also enthralling. And of course, the good thing is we are recording this one, so a lot more people can listen to this. But thank you for the work you do and the effort that you put into this space and the clarity with which you come. So thank you for all of that and for doing the work you do.
Thanks a lot, Vet, and I hope I was not too pragmatic, because if you would be making this interview 10 years ago, maybe I would be a little bit more hopeful, a little bit more naive. But the more I see, I think, look, you just have to do things. If it meant to happen, it will happen. So yeah, and the financial factor, especially in the area of the sustainable packaging, now cannot be ignored.
Absolutely, and that's what you've been teaching us, that like look at the cost right up front, which is true. And I would say that you have to be you, Alexey. You are unique, and that's the way you come, and you embrace it well, and that's what matters.